Hi, good day everyone. Welcome to our presentation in Fibonacci Sequence. I am Cedric Caldona, your presenter. First thing, what is Fibonacci Sequence? Fibonacci Sequence is a set of numbers that starts with 0. Through some sources, don't include the 0, followed by 1, and proceeds based on the rule that each number. The numbers are called Fibonacci numbers. To create the Fibonacci sequence, we start with 0 and 1. Then, each term is the sum of the two previous terms starting with 0 and 1. The next term is 1 because 0 plus 1 is equal to 1. The next term is 2 because 1 plus 1 is equal to 2, and so on. We can say that the first term is a sub-0, the second term is a sub-1, and the third term is sub-2, and so on. Using this notation, we can make recursive formula for the Fibonacci sequence, where a sub-0 equals 1, a sub-1 equals 1, and therefore a sub-n equals a sub-n minus 2 plus a sub-n minus 1. For example, a sub-3 because n is equal to 3, and 3 minus 2 is 1, and 3 minus 1 is 2. A sub-3 equals a sub-1 plus a sub-2, which in this case is 1 plus 1, which equals to 2, which is the fourth term in Fibonacci sequence. The Fibonacci sequence is probably the most famous number sequence. It is named after Italian mathematician Leonardo Pisano of Pisa, known as Fibonacci. His 1202 book Liber Abaci introduced the sequence to Western European mathematics, although the sequence had been described earlier in Indian mathematics. Here's the problem. Given the 10th Fibonacci number is 34 and the 11th term Fibonacci number is 55, what we need to do is to find the 9th Fibonacci number. Now, to figure out this problem, what we need to do first, use some substitution. Since we know what is the 10th and 11th Fibonacci number, we're trying to figure out what is the 9th number. So, I'm going to substitute the values in. Since the 9 is the missing, we're going to leave it, but we don't know the 10 and the 11, so we list it down. Now, using some basic algebra, we can isolate the 9th Fibonacci number using the inverse operations. Well, how we get the 9th number by itself? By using inverse operation instead of addition, it will be subtraction. So, we need to subtract this and do the same thing on the other side of the equation. 34 subtracted by itself is 0. So, we'll just cancel it out. Let's do that in this side. 55 minus 34 is 21. The 21 is the 9th Fibonacci number. That's how you would determine the missing Fibonacci number. Next, we have the patterns in nature. Patterns in nature are visible irregularities of form in natural world. These patterns recur in different contexts and can sometimes be modeled mathematically. Spiral, or plane curve in general, are known from the days of ancient Greek. Many plants grow in spiral. Often, the number of spirals is a Fibonacci number. Here, we have a plant or an agave. We can see the spirals outline. We have there 5 spirals, and 5 is a Fibonacci number. Next is the bottom of the pine cone, and again, we can see the spirals, and we have 13. 13 is a Fibonacci number. Here are some additional examples of Fibonacci spiral in nature. Here, we have the shell, the spiral of a plant, a storm, or a weather pattern, and here we have the spiral in space. Next, we will talk about the packing problem. Packing problem is a class of optimization problems in mathematics that involve attempting to pack objects together into pieces. Okay, so this will be the first part of our packing problem. Suppose we have circles with a radius of 5 cm each, of which will then have an area of 5 cm squared. We are going to fill a plane with these circles. using square packing and hexagonal packing. So, we will take up first the percentage of the squares area converted by circles. Then, we will use area of the circles divided by area of the square and multiply by 100%. To continue, we have here the illustration. So assuming that this is the scenario, we have to inscribe a circle inside the square, but before that, let me introduce to you the measurement or the size of our objects. So, we have from the center point of our circle to the end point, we have 5 centimeters. As our radius, we have 3.1416. The measurements will be the same with the others. Okay, so logically, in order to connect the 2 points, we can now have a one side of a square. That is from this point to that point. That means to say, the one side of the square have a size of 10 centimeters. Okay, so let's proceed to the solution. We have this formula. Area of the circle divided by the area of the square multiplied by 100%. So, we have the area of the circle which equal to the pi r squared, wherein our radius is equal to 5 cm and phi has a value of 3.1416. To continue, we will simply substitute the approximate value of pi and the value of radius to the power of 2. So that means to say 3.1416 multiplied by 5 cm squared. 5 cm squared is equal to 25 cm squared. So it's gonna be the area of the circle is equal to 3.1416 multiplied by 25 cm squared. That will be equal to 78.54 centimeters squared. Now, we have the area of the circle. So next thing to do is simply find the area of the square, and the formula is area of a square is equal to s to the power of 2, where s is the side of the square, which is the sum of the two endpoints. So we have 10 centimeter. So the size of the side of square is 10 centimeters. Next, we will substitute the value of s. So we have 10 centimeters to the power of 2. That results 100 centimeters to the power of 2. So that is the area of the square. Now, let's go back with the formula of the area of circles divided by the area of square multiplied by 100%. This formula is being used to get the percentage of the square's area covered by circle. So let's begin with the area of the circle, and we have 78.54 centimeters squared. Then the area of square is 100 centimeters squared. That will be multiplied to 100%. Next thing, let's do the cancellation. Let's cancel the centimeters squared. Then proceed to calculation. 78.54 divided by 100 is 0.7854 multiplied by 100%. So we have 78.54%. Okay, so the percentage of the squares covered by a circle is 78.54%. That's all. Thank you for watching.